Section 8.1.17, suppose a simple random sample size of n is equal to 17 is obtained from a population with a mean of 71 and a standard deviation of 12. In Part A, what must be true regarding the distribution of the population in order to use the normal model to compute probabilities regarding the sample mean? And then, assuming the normal model can be used, describe the sampling distribution of the mean. So, well, if a random variable x is normally distributed, then the distribution of the sample mean is normally distributed. If the sample size is large enough, where n is greater than or equal to 30, the sampling distribution is approximately normal regardless of the shape of the population. Now, the sample size must be greater than or equal to 30, or the population must be normally distributed in order to use the normal model to compute probabilities regarding the sample mean. Now, assuming that the normal model can be used, okay, we want to determine what is the mean of the sample mean and what is the standard deviation of the sample mean. So the first thing is we know that the mean of the sample mean is going to be the mean of the problem here, so we know it's going to be 71. Okay, and then the next thing that we want to do is we want to find the standard deviation of the sample mean, and that's equal to the population standard deviation divided by the square root of the sample size. So we know that the sample size is 17, and we know that the standard deviation is 12. So let's go ahead and solve here. So it's going to be 12 divided by the square root of 17, and rounding it to 2 decimal places gives us approximately 2.91. So therefore, there is your standard deviation of the sample mean and the mean of the sample means. Okay, now let's take a look at Part B. So again, now assuming that the normal model can be used, we want to determine what is the probability that the sample mean is going to be less than 73.7. So what we want to be able to do is we want to be able to find the probability that x bar is less than 73.7. And so now what we want to do is we want to convert this into a z-score. So z is going to equal x bar minus the mean of the sample means divided by the standard deviation of the sample mean. So what we end up getting is 73.7 minus 71 over 2.91. So we end up getting a z-score of approximately 0.93. Okay. So again, what we've done here is we've gone from a bell curve that had a mean of 71, and what we were trying to find is the area that's going to be less than 73.7. And so what we've done is we've now created a normal distribution that has a mean of 0, and using now a z-score to be 0.93, and we want to find the area to the left of that. Okay, so what we can do is we can go ahead and solve, knowing that if we find the probability of the z-score to be less than 0.93 by using the table. So if we look at 0.93, so there's 0.9 and there's 0.03. So we get the probability of 0.8238. So the answer is 0.8238. Now, if we wanted to use the calculator here, then we would use the normal CDF with a lower bound to be -9999, with an upper bound to be 0.93, with a mean of 0 and a standard deviation of 1. And therefore, there we get our same probability that we got by using a table. And if we wanted to use StatCrunch, then we know that our mean is 0, our standard deviation is 1, and we want to find the area that's going to be less than the z-score of 0.93. And so therefore, there is our area and our probability. So now let's move on to part C. In part C it says, assuming the normal model can be used, now we want to be able to determine when the probability of x bar is going to be greater than or equal to 72.8. So similarly what we did in the first part, okay, what we want to be able to do is we want to first find out what is the probability of x bar to be greater than or equal to 72.8. Okay, so we want to be able to convert this by converting this into a z-score. So recall that x bar represents 72.8, and we're going to subtract the mean of 71 divided by the standard deviation of the sample mean, which is 2.91, which gives us a z-score of approximately 0.62. So again, let's just take a look at what this would look like. So if we had our graph, we know that our mean is 71, and we have 72.8, and we want to find the area that's greater than that. And so what we've done is we've created a normal curve with a mean of 0 and a z-score of 0.62. And we want to find the area to the right of that. So what we want to do is find the probability that the z-score is going to be greater than 0.62, and if we're using a table, we're going to take 1 and subtract the probability of the z-score being less than 0.62. So we want to find the area there if we're using a table. So we're going to take 1 and then subtract, okay, the area there for, let's take a look at 0.62. So 0.62 gives us the following area, which is 0.7324. So we take 1 minus 0.7324, which gives us a probability of 0.2676. Okay, now how would we use this for our calculator? Well, again, we're looking for the area to the right of this. So if we wanted to use our calculator, then we would use, again, normal distribution, normal CDF. And then we know that our lower bound is 0.62 and our upper bound is 9999, since we're looking for the area in the green, with our mean of 0 and our standard deviation of 1. And so therefore there you can see what we get from using our calculator. And then what we're going to do is we're going to use StatCrunch. And so StatCrunch, using the normal curve calculator. So we know that our mean is 0 and our standard deviation is 1, and we're looking for that value to be greater than 0.62. So we're going to go ahead and calculate that. And again, we can see that we get the same area that we found with using our calculator and also using the table.